Okay, some actual limit problems on this document. The idea of a limit is kind of being introduced here with some simple problems. Well, they end up pretty simple. It says find the limit if it exists. The question when we say the limit as x approaches 9. And I'm going to write that out because the symbols are maybe new to you. The limit as x approaches 9, that's what that little arrow means, of this function, is asking what is the output of this function approaching when x approaches 9. When the input is near 9, what is the output going to be near? What's going to happen if you use values close to 9 and substitute them into there? Well, one easy way to start doing the exploration to what that limit might be would be direct substitution. I think normally what happens when x is close to 9 would be pretty similar to what happens when x is 9. So we try f of 9 here. We see what happens when x is equal to 9, and our function looks like 10 times 9 plus 57. And nothing weird happens. Maybe it's a little weird. That comes out to 147. And if you're into simplifying radicals, and you should be, you might pick up on the fact that 147 factors nicely into 49 times 3, so it can be simplified to 7 radical 3. That would be the value f of 9. Now, since nothing strange happens, in cases where nothing strange happens to that function, the limit is going to be equal to f of 9. As x approaches 9, we're going to be close to f of 9. If I used values very close to that, everything in here would be very close to what it ended up being, so no big changes in that. It's a nice simple function around that point, and since nothing strange happens, it's just equal to f of 9. It's not always going to work out that way, but it does for problem number 5 here, and it does for problem number 6. Similarly, as x approaches 0, we try direct substitution. Direct substitution in this one says, what is f of 0? What if I just see what happens at 0? And I got square root of 15 plus cosine squared of 0. That's the cosine of 0 squared, which is 1 squared. So I got square root of 16, just comes out to 4. Now what happens if I take values close to 0, which is really what the question is? Well, if it's close to 0, then the cosine of 0 would be close to 1, so nothing strange would happen in that. It just comes out to a nice number. Nothing strange. So we just got f of 0 is 4. We think this limit is going to equal 4. That's not a proof, but that's pretty good evidence that that function would be, that limit would be equal to 4. So the limit exists and is equal to 4 on this one. If we take any value real close to 0, we're going to get stuff real close to 4. That's what that means. One to go, of course, where something strange does happen.